Well, I don't know about you, but I am scared to use the toilet now. I think that the speakers so far have been amazing. It's been really educational from a lot of different aspects. So today I'm going to be talking about accelerating AI, which is kind of scary actually, following that kind of presentation about all the things that could be done, and I'm going to try to help you make it done faster. So I think it's very interesting where AI is today. It's a priority for all sorts of businesses. In fact, almost half of all enterprises that are going through a digital transformation project, 40% of them are actually having some level of an AI service embedded in that system, in that initiative. And that's actually going to lead us to half of the enterprises having an AI infrastructure in their data centers by 2021. So, as David had mentioned, it's not a fantasy. This is real. This is something that's happening right now for our customers and what we're seeing in the world. And there's a reason for it, because there's a lot of different use cases. There's been a lot of examples mentioned already today. I think I think everyone here has kind of seen AI in use in some way or fashion. Perhaps you are looking at it from a, perhaps you've seen something around how medical companies are using AI to improve CT scanning, to decrease the time it takes actually to perform the images, but having the same level of quality, which ultimately reduces the amount of time that the patient's actually in the CT scanner, making it easier for them, but also reducing the amount of radiation they actually receive. And that is very important for some people. Or perhaps you've seen facial recognition or object identification through security cameras, which allows security teams to possibly find a lost child in an airport, only by knowing the child has a yellow hat and a blue backpack. So these are things that exist today and that companies are actively investigating in. So there's a lot of good things that are coming out of it. And if you're in the Bay Area, which probably most of you are, you probably run across a self-driving car almost once a month on the road. You just see one. And if you're down by Google or NVIDIA, you probably see one once a week. They're just everywhere in the South Bay. So in government, I think we see the same sort of things. Deloitte did an analysis last year, and they did an investigation on how AI could affect government, and found that government agencies that actually invested in technology did see a return on their investments based on the level of effort that they put into them. And they saw the biggest thing, which actually kind of was mentioned a little bit in David's presentation, is that they saw the largest areas of improvement around in labor force, up to 25%. And most of that was helping them handle activities or tasks that employees were doing today that could be easily augmented or supplemented by AI, which helped them reduce their costs, reduce backlogs, move around, overcome resource constraints, improve accuracy, and ultimately, like I said, lowering costs. So it freed those individuals, hopefully, to do other more complex tasks in the business, which may be more rewarding. Well, that's what we hope. So AI can do a lot of things. The question is, how do we unleash the power of AI with the data center? There we go. So the first question, and the one that I get most often, is where would I run my AI infrastructure? And the story hasn't changed much from what we've seen in the last decade, especially the last 5 years, about where does it make sense to run a solution that we're trying to put in. Do we want to run it in the cloud? Do we want to run it on-premise? Do we want to do a little bit of both as a hybrid system? Where does it make sense to run our AI? And the reality is that each of these locations have pros and cons, and there's nothing different than, for AI than existed for other technologies that we've been looking into. So cloud is really great if you want to start up quickly and burst and be agile, but comes with a price tag sometimes. Or maybe there's a compliance concern there, or a security concern. The on-premise stuff is really great if you do have those security concerns and you want to keep data close to the chest and inside your data center, but perhaps it's not as flexible or agile as you want. But you also want to maybe leverage your existing infrastructure if you can. But the problems are that maybe, like I said, it's not agile enough. And then my personal favorite is hybrid, which is the mixture of both, using both sources for what they're best at. And in the end, the choice is hopefully yours. If it's not already being dictated by management or by regulation, you have some flexibility about what you want to do. But no matter where AI, your platform and solution exists, the primary focus on the infrastructure for AI is around performance. It has to be fast. It has to use your data, and it needs to be available when it needs to run. And it really should be flexible to exist in any of those locations as necessary. So something that really can leverage everything. Oh, I went backwards. There we go. So to solve that, what we're really looking for is a data fabric that can spread across different data center types. A single platform that can unify data management no matter where the data resides, which allows us to securely control that data and protect it, whether it's in flight, it's in use, or it's at rest, and can move around seamlessly and maintain compliance if we require it. Additionally, using the same technology types in those different areas allows us to seamlessly change from one area to another without impacting the business. And that's an important statement. And then getting back to the fast part, it's important to have that speed, because AI architecture in general needs to deliver data to the hardware and the systems that serve it with very low latency and high bandwidth to ensure that you get the best return on your investment for what you're spending at. So to us, in the end, what you really are looking for is a proven architecture that's a reference architecture that you can use across the board. And something that's been validated and tested and will guarantee that what you're expecting is what you're actually going to get, no matter what size it is. I got my 10-minute mark there, thank you. And where it's located. So one of those reference architectures is by NetApp and NVIDIA. If you are not familiar with NetApp and NVIDIA, NetApp makes storage systems, and NVIDIA makes graphic process units, GPUs as they're known. And really, the reference architecture is the concept of simplifying and accelerating and integrating your data pipeline with a proven architecture. And it's powered by NVIDIA's DGX systems, which are GPU-based supercomputers, and NetApp cloud-connected storage that's all flash. Now, I know that's very technical, but that allows AI platforms to really excel at what they're doing. A little bit about the DGX as well, which you can see in the bottom half there of the rack unit. It is GPU optimized. It's been designed by NVIDIA specifically for AI workloads and for individuals and companies that want to invest in that area. So it's not like the video game cards that you can buy at Fry's or Best Buy. They're designed for the data center in mind. And they're fully integrated, and they have unbelievable performance, which I'll show you actually in a few minutes here. So just a real quick thing, if you're not familiar with what the difference is between CPUs and GPUs, CPUs are really great at handling simple, more complex calculations sequentially, so one after another, while GPUs are better at handling multiple but smaller and more simplified calculations in parallel. And you can see the difference here in the core technologies. CPUs, I think the current most highest core count you can get in a single chipset processor now is 72. If you got the latest and greatest thing, which nobody buys unless you're making massive data center computers or supercomputers, or GPUs, which scale into the thousands of cores, so they can handle it much faster. And I'll give you an example of the difference here. So if we can start that, oh, there you go. It keeps going back. Oh, Let's try that. There we go. Thank you. So this is an example of TensorT, which is an inferencing solution. It's an algorithm to look at and identifying, in this particular case, types of flowers. And this is based on a single processor, a single Skylake CPU made by Intel. And this is the speed at which it can do, which is approximately about 5 images a second. Now, if we look at one of NVIDIA's V100s, it can do 900 images a second. And if you think about that in the world of smart cities, when traffic patterns are changing and when decisions need to be made, that's the difference. Am I waiting 5 seconds or am I waiting several minutes for an answer to come out? Or do I want something very quickly in a few seconds? Now, one of their other lines is the DGX1, which is actually a single supercomputer as part of that architecture. That can process 7,000 images a second. And so again, you're seeing the difference when decisions need to be made or when things have to happen very quickly on your IoT devices. The difference between GPUs and CPUs is noticeably different. And so you have to think about that when you're actually developing AI or developing systems that are going to be based on it, especially, in my opinion, when there's an end user at the end of this or a person that's relying on that technology. Apple and Microsoft and Amazon are betting on that technology, and so you should be aware of it. Oh, go back. So just a few final thoughts on this. One of the things that I recommend to my customers is that don't shoot for the moon. Low-hanging fruit is actually a great place to start with AI if you haven't gone into it yet. The reason is if you look at activities and tasks that you're doing inside your business, this is it's finding the small micro issues that you can improve upon actually are great ways for you to start, because then you'll learn how the process works. Do you have good data? Does the data make sense? It allows you to make more of it, and you get education also at the same time. Using a validated reference architecture really does help you scale and get the performance, especially if you're actually making business decisions or financial decisions on that data. I would also add to this that your data, what you have, is important. One of the biggest challenges that we see with customers is they think they have data that will be great. They go, wow, we can do this and it'll be great. We have all these records, we'll just digitize them, or we already have them ready to go and it'll be great. But AI is very much based on garbage in, it will be super garbage out. So you need, in order to train good models, you need to have good data that's labeled properly and understood, and so that you get good informed decisions, which I think you'll hear from a lot of data scientists that work with it. A big thing like we're doing here today, talk to your peers, talk to trusted advisors. One of the things that we offer our customers are what's called ideation workshops, where we invite people to come out and be part of a large audience, and we say, what are the types of challenges you're having, and try to come up with ideas where AI would be a good fit or not a good fit, or yes, that's a great idea, but that's extremely complex, or this is a really great use case or great starting point. It's a really wonderful way for people to see what the potential possibilities are. And in a lot of cases, what we find is people say, I didn't even think of doing that, and that would be amazing to do. And it turns out to not be that complex because the tools may already exist for them to do that. And the last thing I would say here is play and learn and grow. Like all systems where you have to jump into a new technology, AI is something that you can practice on your own, actually, if you want. And NVIDIA this year came out with a very small device called a Jetson Nano, which is a single GPU. You can pay, I think it's $120 or something like that. Huh? It's $100. It's a little thing you can sit on your desk, and they give you a bunch of modules and installations on a wiki page to say, all right, this is how you can start by doing image classification. Like, is there a dog in this picture? I actually used it to identify if they could see my dog in a family photo. And Thank God it did, and it didn't say I was a dog. But it works, and it allows you to learn. And so if there's people in your organization that are interested in learning it, that's a very low way to start. $100 and then time just to play around with it, something that sits on a desk. I actually know people that have taken that and have turned it into almost a Ring doorbell system, and actually does facial recognition on people that ring their doorbell. So it's tiny and small, it's not super powerful, but it gets you the ability to start learning. So I do recommend that. How much time do I have left? I have 1 minute. So the one thing I'm going to finish up with is, we talked a lot about some of the scary things that happen with AI, but one of the things that's close to our CEO's heart is Human Rights Watch. And Human Rights Watch, if you're not aware of them, they are a humanitarian organization that looks for atrocities in the world. And they are actually using AI for something very interesting. So you can see some of their presentation actually up on the GTC website, the NVIDIA's conferencing website. But what they're doing is they're actually looking for, through satellite images, which historically they had someone just manually looking at images from Google Maps, for example, every day, looking for if villages were on fire, if something horrible had happened. And if you imagine going through your town on Google Maps and trying to find when somebody moved their car, you can imagine how impossible that is. And what they're using with another company called Element AI is they're actually using those images and comparing every single day to notice patterns and differences. And from that, they've actually been able to identify also villages that they didn't even know existed, that are almost impossible to find in parts of the world. So they are able to do this kind of use these kind of technologies for really good things. So there's always an ethical decision to be made, and there's always things that can be done for the human good. There are ways to improve our lives. There are definitely, as Lane had mentioned, there's some scary things there too. But hopefully, it's up to us to make sure that we're promoting the good stuff. So with that, thank you very much. I really appreciate it.